This lecture we try to discuss few things which are related to the key based the crypto primitives. So as we saw in the previous lecture, we learned about the hash function, the secure hash function, and we have seen the basic properties of your hash function. That the collision free, that means for any two different inputs it should not generate the same digest. So then we say it is a collision free, and information hiding means instead of sending the original message, the digest can be sent to the receiver. So receiver can use the same algorithm to generate the digest by using the same input. And then we have seen how these hash functions are used as a hash pointers in the blockchain system and their data structures. So in the for hash pointers, we followed the mechanism of your Merkle tree. The Merkle tree, every input message is separately the hashed, and it follows the binary tree mechanism. So it can join the leaf nodes to generate the intermediate nodes, and all intermediate nodes try to generate the root node. So in today's, we try to discuss the public key cryptography, which explains how this public infrastructure supports the network security and how it will be applicable to our blockchain system when any individual who generates the blocks and maintain the blocks in the blockchain system. So first and foremost, the properties of your public key cryptography is why this public key cryptography used means to provide the CIA. One is confidentiality, integrity, and authenticity. So once these three properties are, make sure to send a data from source to destination by providing the data is securely transferred through the network. So in data integrity and authenticity, it explains the cryptographic while ensuring the integrity and authenticity of your data during the transmission through the network, the open network. And confidentiality purpose, it uses the key concept. So that approaches the symmetric key and asymmetric key concepts, we talk about them. And then how these keys are going to be distributed among the users so that the CIA property can be maintained. So this is the basic objective of today's lecture. So in the integrity and the authenticity part, any organization that provides some security for the securing the communication by following the cryptographic method. So this the organization must provide the data internally as well as externally. So there are four elements of securing these communications. One, as said, the data integrity, authentication, confidentiality, and along with these three, CIA, there one more important one is data non-repudiation. Okay, that means in data integrity, it guarantees that the message was not altered when it is transferred from source to your destination. That means the message was not altered by any of the attacker or the malicious nodes in the network. Where authenticity, it guarantees that the message is not forgery and it actually comes from whom it states. So it gives that only the legalized sender has sent this message, and upon the approval of or agreement of both the parties, the messages are exchanged between source to destination, destination to your source. So that it gives the authenticity or authentication part. And confidentiality, that guarantees that only the authorized users, only the authorized sender and receiver can read that message. No other users can decode that one. that gives the confidentiality. And the non-repudiation, the data non-repudiation guarantees that sender cannot repudiate or refute that the validity of the message sent. So he cannot deny it after that. So these are very important the part in the communication. So in this how they are going to be achieved. That means one is your cryptographic hash function, as we discussed in the previous lecture. So there will be any arbitrary length of your plain text that will be given as an input to your hash function. So hash function generates the fixed length of your hash value, but there is no, it is a one-way process. Okay, the hash function can simply compute a fixed length of your digest. So this is one way. So with this hash functions, it is computationally infeasible for two different set of data to achieve that it's collision free, and it uses the pre-image and second pre-image and collision resistant properties that we have already observed. And then, as we said that the properties of the operations of your hash function, it takes any fixed length input, gives the fixed length output, and it gives the h of x is a one way and not reversible. It's collision free, meaning that two different input values are not result in a different. So these are just to recall you from the previous lecture. So these are hash functions. There are two groups of hash functions. We have seen different groups of hash functions or families. One is MD5 and SHA. SHA is having three different the categories in that. That is depends upon what is the bit size of your hash message. That is, SHA produce 160 bit size hash message and is slightly lower than your MD5, whereas your SH2 it produce the 256 or 384 or 512 hash values. But for our blockchain, we are using the SHA 256 part. So this, we discussed that this SHA functions, it's design part of your secure hash algorithm that we discussed in the previous class itself. So then, what is the main important of these hash functions means they can simply used whether the data is altered or not. So while hashing is used to detect the accidental changes, but it cannot be used to guarantee against the changes by any of the malicious nodes or the attackers. So there is no unique identifying information from the sender in this hashing procedure. So this means that anyone can compute a hash for any data as long as they have the correct hash function which is used by the receiver. So therefore, hashing is a vulnerable to man-in-the-middle attack. So any third parties, they can change the message and they can compute the new hash value, and that new hash value will change, send to the destination. So destination also use the same plain text message, and that same plain text is given to the same hash algorithm. It will generate the same digest. Okay, so there is no the guarantee that the message is changed by the only sender, the authenticated user. So how to give the authenticity for this hash value then? Only the authenticated legal user send this message. So for that, it requires a method called the origin authentication. So this is most important in the blockchain also. Who is creating the block? Only the authorized user or network, user in the blockchain, they created the block, or any the attackers, they created the block. To identify that, the authentication is most important in the network. So to add the origin of your authentication and give the integrity assurance for any of the blocks or messages generated by the users in the network, it uses a key hash message authentication. Key hash message authentication. That means it uses the hash function as well as a key. So when we talk about the key, it leads to a public key infrastructure. It leads to a public key infrastructure. So to get the data integrity and its authenticity, the cryptographic origin authentication method used, that is HMAC, the hash message authentication code. So this HMAC uses the additional secret key as an input to the hash function. So here, what is secret key? The secret key is a concept of your public key infrastructure. So in this public key infrastructure, it generates the keys. One is public, another one is private. One is public and private key. So in this public and private key, the private key kept by the sender or original user, and public key is distributed to the users in the network. So when public key distributed to the users in the network means to whom? Is it to every user in the network or to only the specified users? So there we talk about the public key infrastructure or the key distribution schemes. So in that key distribution scheme, there will be a trusted third party. Every individual users in the network, they generate two keys, they keep one key with them, and they keep public key with the trusted third party. If any other receivers, they wants to communicate with the sender, they first contact the trusted third party to get the public key of sender. So that, the key distribution scheme that we'll briefly discuss at the end of this this topic. So these secret keys are used along with the original message as we used in the hash function. So the arbitrary length of a hash, the arbitrary length of message plus the secret key given as an input to your hash function, that will generate a hash value, the digest. Now that digest go through the network, in a peer-to-peer network or in a distributed network, and once that digest is received by the receiver separates the plain text with the digest, then use the same plain text and the key of your sender, which they already shared using public key infrastructure. So same plain text and key will be given to the same algorithm at the receiver side, and it generates a digest. That digest compared with the received digest. If it is matching, that means your plain text, your message is not altered. If not matching, that means your plain text is altered. So in this case, how it is achieving the authentication means the receiver is using the key of sender. Receiver is using the key of sender only. Okay, so that means the message which is generated by a sender, the same message received by the receiver, to ensure that the key plays a major role for the authentication.
But isn't the key shared with a third party?
Yes.
So I'm a little confused on how.
We call that as certificate authority. We'll talk about
Okay.
that. Yeah.
Okay.
So that certificate authority will distribute the keys. So how that key will be distributed, that's a different big story, but we'll briefly describe by using the threshold secret sharing key mechanism.
Okay. Is it the sender's public key that's being used in the hash that's being sent, or is it their private key that's being used?
If it is a concept of digital signature, in digital signature, sender use the private key for encryption,
Okay.
and receiver use the public key.
For decryption.
If it is other than digital signature, if any other encryption method, sender either can use the public key or private key. If using public key, that means private key will be distributed.
Okay.
If using private key for encryption, public key will be distributed.
Okay.
Yeah. So here you can see the process of that as just explained, the origin of your authentication process. So the plain text message with the data arbitrary in length and a secret key of your sender. So both are given as an input to your hash function, so it generates a fixed length output. Okay. Now whatever key is there, this key is a shared key with the sender as well as the receiver. So both are having these keys. Okay. So upon receiving this, by creating the hash value, your plain text, whatever the data is there, that data is concatenated, merged with your secret key. Then it will generate one hash function. So that the digest value, that digest is concatenated with the send along with this plain text. The plain text and this one is your digest. So both are sent to your receiver side. So now, upon the receiving this message by your receiver has to verify this, whether that message sent by this user or not. So receiver, what you will do upon the receiving this message from the sender, it separates this digest from your plain text. So that plain text and the secret key which is already shared between both the parties, because this key belongs to the sender's key. Now using the same key, giving as an input to message plus your secret key, giving as an input to your hash function, it generates one digest. Now this digest and the received digest, the comparison, bitwise comparison will be done. If both are matching, that means the message is received securely without any alteration. And how it is giving the concept of your origin of your authentication means for the verifying the HMAC value using the same key, so that achieves this authentication. Only the authorized user is given that. So this is the concept of your HMAC, hash message authentication code. Okay, so by this you can achieve the data integrity as well as the authenticity of that particular data. So for example, in the networking, if you see that there is a concept that the network devices like your routers, they basically used to find a route from source to a destination, or find a path from source to destination. So to find a path from source to destination, they run a routing algorithm, routing protocol. So different routing protocols are used. So those routing protocols will have the route from source to destination. So assume that the router 1 is trying to share this information about the link state algorithm, that is the shortest path first algorithm, routing information of network address is 10.2.0.1 by following 16 bits for network address, remaining 16 bits for your host address, and the IP address of this is the network address, and the IP address of that R1 is your 10.2.0.1. The type of link is the fast Ethernet, so some information is there. So then router follows this HMAC procedure. So in HMAC procedure, along with this message, router will have the secret key of your router 2. So along with that message, router 2 secret key given as an input, it will generate one hash value. And this hash value concatenated with the message, and that will be sent to your router 2. So upon received by router 2, separates this plain text from this, and this plain text and its secret key given as an input, if both are matching, that means this routing information is not changed by any of the attackers. If not matching, that means some attackers changed this routing information. So why in this example shows that if this routing information suppose altered by any of the third party user, that the router R1 and router R2, the path between R1 and R2 is exist by saying router 3. So that message, the same message, actually there is no path which is supposed down, but R3 use this plain message and generate suppose message that there is a path exists between R1 and R2. So what happens? Router R3 is trying to get all the information from other routers, like from R4 and R5. So then this router looks like a man in the hole attack, or tunneling attack, we used to say in the network. So it's tunneling that and play as your black hole attack. In this black hole attack, actually there is no path, but informing others that there is a path from R1 to R2 that is possible from R3, but actually there is no path, there is no connection between R3 to R1. So what this R3 router is trying to do is trying to collect all the information and trying to inspect that information. We call that black hat attack. So to avoid that, this HMAC follows upon receiving the message from your R3 by your R2, the secret key of your R2 is available with only R1, not with R3. So R3 cannot digest the same digest which is generated by your R1 router. So simply detects that the message which is coming from R3 is not correct message. So simply they will be dropped by your R3. So that way it secures the network, and that way it can detect the attackers. So that is the data integrity part and authenticity. So data integrity can be done using hash function, and authenticity can be done along with hash function. Key will be required. It comes to the confidentiality. As we said, confidentiality means only authorized users can read the messages. Unauthorized users or the attackers, they cannot understand what is there inside the message. So to achieve this confidentiality, then there is a method we called, two different methods are used. One is by following the symmetric key method or asymmetric key method. Symmetric key or asymmetric key method. So these are two different class of your encryptions which are used to provide the confidentiality. So in symmetric key and asymmetric key, in symmetric key means it use the same key for encryption as well as for decryption purpose. Whereas your asymmetric key, one key is used for encryption and another key is used for your decryption purpose. So in symmetric key encryption algorithms such as your data encryption standards, DES or triple DES or AES, they are based on the premises that each can communicate parties knows the pre-shared keys, the same key. Suppose sender is using key 1, so receiver also use the same key 1 for decryption purpose. So the data confidentiality that can be ensured using this asymmetric algorithms also called the RSA algorithm or by using the public key infrastructure. RSA algorithm and your public key infrastructure. So these RSA algorithms are used to generate the RSA algorithm that Ravish, Shamir and the Adelman, three authors, they developed this algorithm. They use to generate the keys, and once the keys are generated, those keys can be shared by using secret sharing mechanisms in the distributed networks. If there is no central authorized trust parties, in that case it uses the distributed secret sharing mechanisms are used for that. So if you see the symmetric key, where the symmetric key encryptions are basically used means in the virtual private networks to reduce the traffic between your sender and receiver. So these symmetric key algorithms use the same key, and that will be pre-shared between the sender and your receiver side. And the same key is used for your encryption purpose and the decryption purpose. So these algorithms are commonly used in the virtual private network traffics because they use the less CPU resources, because the computations are less there. There is no much computations here. So the mostly in this symmetric key, the size of key should be smaller so that the computational time required is smaller, so the communication can speed up. So generally it lies in between your 112 to 256 bits in length, the key size for symmetric keys. So these symmetric encryption algorithms are sometimes classified as your block cipher or stream cipher algorithms. That means what? If you have any message, that message is divided into equal sized blocks like block 1, block 2, block 3 and so and so, and same key is used for every block. And on receiver side, upon receiving these blocks, the receiver will decrypt each block and arrange all those blocks together to generate an original message. If any one block is suppose corrupted by or attacked by any of the user, the message cannot be generated in this. So in block cipher, as we said, the block cipher that divides the plain text into fixed length blocks like 64-bit blocks, and every block goes through the applies a key for that, and then that encrypted the 64-bit blocks are transmitted via the through this network. So what is the advantage of this block cipher means? Your entire, if any attackers are there or man in the middle attack is there, they may attack few of the blocks, not the entire message blocks. So if few blocks are attacked, then for those blocks, the receiver will give the error message, the negative acknowledgement. Upon receiving the negative acknowledgement by your sender, only those blocks can be retransmitted in the network. So the network load will be reduced if attackers are there. So this is one way of the decreasing the congestion, or one way of congestion control in the network. Another one is your stream ciphers. This stream cipher is similar to your block cipher, but in the stream cipher, either it can use the encryption for bitwise or a block size. So what block size? The maximum block size of your stream cipher is 1 byte. And that the stream of your bits are transmitted from source to your destination as in the form of your encrypted messages. So these are two different methods. So the well-known symmetric, the encryption algorithms are your DES as said, triple DES advanced encryption standards, your software optimized encryption algorithm, and your RC algorithm, we call the revised cipher series algorithms are there. So how they are defer to each other means the DES that uses the short key length, where the triple DES is the replacement of your the DES with the repeats the DES algorithm 3 times instead of 1 time, whereas your advanced encryption standards, it offers the combination of 128-bit to 192-bit or 256-bit keys to encrypt the 128-bit to 256-bit long data blocks. Whereas these software optimized encryption algorithm, they use the 160-bit encryptions like your SHA algorithm type. Okay, and then comes to the asymmetric key encryption. As said, it uses, there will be 2 keys. One key used for your encryption purpose, another key is used for your decryption purpose. So this asymmetric key algorithms are, both the keys are capable for your encryption process as well as your decryption process. That depends, but the process is also reversible in this case. So these asymmetric key algorithms achieve the confidentiality, authenticity, as well as the along with that, if it use the hash functions, then the data integrity is also used. So the key lengths which are used in asymmetric key are generally between 512 to 4096 bits. The very long keys are used to secure the data. So when the key size is increased, the computational power is also increased. So that's why the asymmetric key algorithms are substantially slower than your symmetric encryption algorithms to achieve the confidentiality of your data. So the asymmetric key, the most used algorithms, encryption algorithms, are the Diffie-Hellman algorithm. We use the key length from 512 bits to 4096 bits. Whereas these are all key generating algorithms, whereas digital signature standard DSS or digital signature algorithm, they use the key length in between 512 bits to your 1024 bit in size. So there, to generate the key for private key and public key, it uses the RSA algorithm or Elgamal signature scheme. And the third one is elliptic curve techniques are used. So these cryptographies are used to adopt many cryptographic algorithms such as the Diffie-Hellman and your DSS or Elgam. The asymmetric encryption methods are used. So finally, to say that the asymmetric key encryption, how it is achieving the confidentiality means, it is a process of your public key infrastructure. So public key plus your private key for decrypt, that gives the confidentiality. Along with this, if it uses the HMAC, that achieves the integrity as well as your authenticity. So by achieving these three, you're going to give the CIA triad to give this full security for your data. Okay. So in this case, when the private key is used to encrypt data, the corresponding public key must be used to decrypt the data as said. So this is a concept of your digital signature. In digital signatures, the private key is used for encryption purpose to encrypt the digest, and public key is used to decrypt the digest. Okay, so these concepts please be clear, because this is your first lab assignment. You need to develop a code for your the digital signature. Create a first you need to generate the keys, then you need to share the keys, then do the encryption and decryption for verification purpose. Yeah.
So if you wanted to be authentic with one of with the message you send, you would encrypt your plain text with your private key.
Yeah.
And then you would encrypt that again with your receiver's public key.
No.
No?
If you are a sender,
Yes.
you will encrypt the key with your private key.
Okay.
And I will decrypt that with your public key.
Okay.
So you will share your public key with me. Please.
Yes. But how then, if I meant it for you, how do I know, because public key is something that's known, how do I know that someone else hasn't intercepted it and opened it with a public key?
Yeah, that is what there is a trusted third party called certificate authority.
Okay. Keep it. Okay. Thank you.
Yeah. Yeah, so this is the few of the examples that use for the private and public keys can be used for the providing authentication to the data exchange. Like Alice wants to send some message. Alice use Alice private key. So Alice private key and Alice plain text given as an input to your hash function to generate the encrypted text. The encryption algorithm. This encryption algorithm may be your DES algorithm, or the triple DES or AES algorithms. It will generate the authenticated, the encrypted text. So when this encrypted text given to Bob, the encrypted text Bob applies, use the Alice public key to and give the same algorithm. Give these two as an input, the same encryption algorithm to generate the decrypted message. Okay. So here the asymmetric key integrity. So how confidentiality and integrity will be done means, if you see combining two asymmetric encryption process that provides the message confidentiality, authentication and integrity. How? Alice uses Bob's public key. Alice, having a plain text, use the Bob's public key, so encrypted text will be there. That means what? Bob and Alice, they exchanged their public keys. So Alice is having public key of Bob, Bob is having public key of Alice. Okay. To achieve the data integrity, authentication and confidentiality in the single process, Alice used the public key of Bob. Then it generates the encrypted message. That encrypted message goes through the different process. So Alice encrypts the hash using her private key. So the plain text is encrypted with Bob's public key. So whatever the encrypted text is there, okay, so then the Alice encrypts the hash using her private key. Whatever this hash value is there, this hash will be encrypted with the private key. Why? To achieve the data authenticity and integration, that's why the hash value combined with the private key. Now, this Bob uses the Alice public key to decrypt the hash because they already changed. So then Bob uses the private key because the plain text encrypted by Bob's public key, so that plain text decrypted by Bob's private key. To achieve the data integrity and confidentiality, Alice used Alice's private key and Bob used Ali's public key for decrypt purpose. So in this case, both the users, Alice and Bob's, both the users' public key and private key, both are used to achieve the data confidentiality, integrity, and the authenticity. So to achieve the data confidentiality, integrity, and authenticity, what is the procedure? Sender use receiver's public key for message encryption. Next, sender use the sender's private key to generate digest. So now encrypted message plus the digest together goes to your receiver. Now receiver use sender's public key to decrypt digest. If the digest is decrypted and matching, that means data integrity and confidentiality. So once digest is separated from plain text, then it use the receiver use the private key of receivers to open that encrypted, so data confidentiality is there. Perfect. So this way, so this concept is used in the concept of the blockchain technology in the distributed networks. So here the main point is keys. So how these keys are going to be generated and how they are securely exchanged between the users or among the users. So that concept we call the public key cryptography concept. So in this public key cryptography, it will be achieved by the digital signatures. The public key cryptography using digital signature. So these digital signatures are the mathematical techniques which are used to provide authenticity, integrity, and your non-repudiation also. Authenticity, integrity, and non-repudiation. So to achieve the confidentiality, you require asymmetric keys. And for public key cryptography, most important is authenticity. Data should not be altered, and no one deny that block is not created by me. So these digital signatures use the asymmetric cryptography, as we discussed, use two keys. So these digital signatures are commonly used in two situations. One is in coding signing, and another one is digital certificates. Coding signing and digital certificates. So in coding signing is used to verify the integrity of executable code files or executable files downloaded from the vendor's website. So this is what you find if you download or if you are using any legalized softwares. Along with that software, you will find one key, product key we say. So that product key, if you supply that product key, it undergoes through the digital signature process. We call that as your coding signing process. So it is also using the signed digital certificate to authenticate and verify the identity of the site, that is the source of your file. And second one is digital certificate. So there are used authenticate the identity of the system first. So in our blockchain, in cryptocurrency and Bitcoin, identity is important. So identity of your system, to authenticate the identity of the system with the vendor's website and establish a encrypted connection to exchange the confidential data. So how it will be achieved? So there are three different types of digital signature standards are there. One is digital signature algorithms, DSA algorithms, or your RSA algorithm, or elliptic curve digital signature algorithms are there. So these three algorithms are basically used to achieve the authenticity, integrity, and non-repudiation. How? So let us see with an example. Suppose in digital signature, you have the Bob and Alice. They want to exchange the information or exchange the block of your blockchain. Suppose. So what is the first step? If Bob is the sender and Alice is the receiver, the first few steps should be taken by the sender. First step is Bob has to generate the key first by using your RSA algorithm. Okay, Ravis, the Shamir and algorithm, RSA algorithm, generates the keys. So it generates two keys. One is public key, another one is private key. So in digital signature, as said, sender use the private key for doing some encryption purpose. So Bob used his private key for some operations, for encryption operation, and Bob's public key is given to the receiver. Is given to the receiver. Okay. So in this case, the key pair is generated, and one key is private key is with Bob and public key is with the Alice. The next step, when Bob tried to send some plain text or some message. So that message, the first step, it generates the key. The second step, the message, the plain text, is given as an input to your hash algorithm. Whatever the plain text wants to send, that plain text first goes through the hash algorithm. So what happens? Your hash will give and generate a digest. So when digest is there, when hash function is included, means it is trying to achieve the data integrity and your authenticity. Data integrity and authenticity, correct? Right. So plain text is given as input to your hash function. Let us assume that SHA2, that means it generates a fixed length 256-bit digest. Okay. The next one is, once this digest is there, then this digest is given as an input to the asymmetric algorithm, asymmetric cryptographic algorithm. For what? Instead of encrypting this the plain text, the digest is encrypted by the private key of your Bob. So the digest, the private key is given as an input for asymmetric algorithm, and the digest is given. So which part of your the sender's message is encrypted means only digest. Only digest. Okay. So now once it is encrypted, then the digest which is encrypted by the private key of sender, we call that as digital signature. So now how do you define the digital signature? Means the hash value of your sender which is encrypted by private key of your sender is known as digital signature. Am I clear? Yeah. So now this digital signature is added with the text which the sender wants to send in the fourth step, in the fifth step. So these two are joined together in the fifth step. Okay. So in digital signature, what happens? First, sender generates keys. He keep the keep the private key with sender and public key given to the receiver. In the second step, sender generates a hash value, means the plain text is given as an input to hash function, In the third step, he or she will get the hash value, that digest. In the fourth step, that digest is encrypted, so it generates a digital signature. Now that digital signature with the plain text is given as an sent through the network to your receiver. To the receiver. Okay. So now at receiver side, upon receiving this message by your receiver performs certain operations here. First, from this message, digital signature and message, it separates the digital signature and separates the message. Now, once the message is separated and digital signature is separated, then this digital signature, because as we discussed that asymmetric cryptographic algorithms are reversible. So this digital signature is given as an input to the asymmetric cryptographic algorithm, and your Alice is having the public key of, in the sixth step, the public key of, so this is the sixth step happened, the public key of your Bob is given to your sixth step. So by doing that, once it is decrypted, we are able to find this digest. Right? And from this message, the entire message along with your digital signature, from digital signature, digest is generated, and the plain text is there. Now plain text is given to the same hash function which is used by your sender, that is SHA2. Then this hash function generates what? Digest. Now the digest which is encrypted in the form of digital signature and the digest which is generated from this plain text by your receiver, if both are suppose matching, that means the message is perfectly received without alteration. So message is, when digest are matching, message is perfectly received means what? It is achieving the data integrity and authenticity. How it is achieved the authenticity? Because that digital signature is decrypted by the key of sender. So that is the authenticated user's key. So it is authentic. And then there is no, this digest is not altered. That means the confidentiality is also achieved here. Okay. So this process, we call it as your digital signature. Digital signature. Am I clear? Okay. So simply, if you remember that in digital signature, there will be two keys will be there. Private key of your sender used to encrypt digest, not the plain text. And that digital signature is attached with the plain text and it will transfer through the message, through the network. So the same process you can see in this video, in the step-by-step process. Yes. So as both the users are there, they use the asymmetric key concept in this digital signature. So which means the public key algorithm is employed for your digital signature. So then the very first step of in digital signature, sender has to generate the public key and private key. Then private key kept with the sender and the public key will be given to the receiver. So then the sender will take the plain text and that plain text is given as an input to your hash function. So it will generate the digest. Now this digest is given as an input to your asymmetric key algorithm and give the private key of your Bob, so it generates a digital signature. That digital signature combined with the message, and that message achieves the to get the data integrity, confidentiality, and authenticity, these basic operations performed by your sender, then this message will be goes through the network to your receiver Alice. Then what Alice do? First and foremost thing, Alice separate the digital signature from the received message, and that will be given as an input to the same asymmetric key algorithm, and use the Bob's public key to decrypt that digital signature and get the digest. Now, along with that digest, the the Alice received the what you call this plain message. So that plain message will be given as an input to the same the hash algorithm, which is used by the Bob, and that hash algorithm generates the what you call the digest. And if that digest compared with the digest which is decrypted from digital signature, if it is matching, that means the message is received successfully. So there is a data integrity and data the authenticity is there, and data confidentiality is achieved because the digital signature is not altered. Okay, so yeah, so this is the entire process of your digital signature. So what I would like to give you the summary. The first part, you need to generate keys. In the second part, use those keys for your digital signature and your digital signature verification to achieve the data confidentiality, integrity, and your authenticity. So this is the first homework, lab homework, which is given to you. You can use any platform to develop this concept. Use any platform, maybe in Python, maybe in C, C++. In any Python, you can write the code and do this verification. And while you are executing that, try to record a 1 minute or 2 minute of your record while executing the code. Yes, please.
In this example, how is the confidentiality handled? Because it seems like plain text is being sent in a message. I understand the other two just.
Yeah. So the confidentiality, how it is, when it is received here, first and foremost thing, your receiver is checking whether it is the digital signature is mismatched or not. When this digital signature mismatched, if this plain text is suppose altered, if this plain text altered, then from here, the digital signature which you are receiving, that digital signature value, digest value will be changed, right?
Yes.
So when digest value will be changed, when it is decrypted, this digest value won't match.
Yeah.
Won't match means somebody is, changed that. Yes. So blindly you can remember where we use the key. If we are using key for any encryption or decryption purpose, means that is for confidential. If you are using hash function, means that is for data integrity and authenticity. Yeah. So here, these digital signatures are used for your digital certificates. Digital signatures are used for your digital certificates. So in digital certificate, what is the main entity? It needs to identify the authority, who is there, who issued, and what is the validity of that. So digital certificate enables the users or host or your organizations to securely exchange information over the internet. So this digital signatures, it is used to authenticate and verify that a user who is sending a message is who they claim to be. So in digital certificate can also be used to provide confidentiality for the receiver with the means of encrypt a reply. And these digital certificates are similar to the physical certificates, but digital certificates independently verifies and identifies. So in other words, we can say that the certificate verification is an identity and a signature verifies the information coming from the identity. So in digital certificate, there will be a central authority. We discuss that one by one, how it works in the digital signature for your digital certificates means. In this scenario, if you see, if Alice has given a order to Bob through the Bob's website, suppose, like maybe in coffee order or pizza order or anything. So upon receiving that order from the Alice, what Bob will do? Bob confirming that order with the Alice, that I have received that order. Okay. So then what Bob do in the digital signature process? The confirmed order is given as an input to your hash function. So then hash will generate one digest. So that digest is encrypted by the key of Bob. Which key? Private key. So then it generates a digital signature. That digital signature along with the confirmation order, plain text, will be sent, that is signed and sent through the internet to your Alice. Now, upon, on receiver side, what Alice do? Now, Alice will first go and receives this particular digitally signed the document from Bob and separate that confirmation order with the digital signed by your Bob. So then once signature is separated, what do Alice will decrypt this signature with Bob's public key. When decrypt, then inside the signature you will have one digest. So now the Bob from this confirmation order, that confirmation order given as an input to the same hash function which is used by your Bob. So it will generate one the digest. And whatever the signed digest is there and the digest from your plain text, if both are matching, then the Alice says that okay, this particular order came from the authenticated user Bob itself. So the authenticity will be there, data integrity will be there here. So if the hashes are matches, the document is authentic, and this means that the confirmation was sent by the Bob only and has not changed this sign. So once the order is confirmed, then you may go with the payment part. So this is the digital signature with your certificate part. So in the next class, we'll try to discuss the public key encryption, that is the key generation by using your RSA algorithm. So I would like to stop this session here. If you have